All right, we're going to work on divisibility rules and rounding numbers. So this will cover on the test review numbers 19, 20, 21, 22, 23, 24, 25. But how you fill out this chart is really important. I guess for those that are bothering to look at some of these videos, there's a chart very similar on the test, so it's really important to know how to fill it out. These are each of the numbers that they're asking about, and of course you go to the top and you have to decide, is this number divisible by 2? Is this number here divisible by 2? Is this number here divisible by 2? Is this number here divisible by 2? And that's how I'm going to work it. I'm going to go down the column like that. And I'm going to do it on my paint thing. Ooh, that came out funny. 75. Okay. So is 75 divisible by 2? The rule for divisibility by 2 is if it ends in 0, 2, 4, 6, or 8. That means if it ends such that the number is an even number. Any number ending in 0, 2, 4, 6, or 8 is an even number. So, is 75 an even number? No, it ends in 5. It does not end in 0, 2, 4, 6, or 8. So it is not divisible by 2. Is 1800 divisible by 2? It ends in a 0, so the number is even. And yes, it is divisible by 2 because it is an even number. Is 516 divisible by 2? It ends in the number 6, so if it ends in 2, 4, 6, 8, or 0, it's an even number. Therefore, yes, it's divisible by 2. So notice how I'm filling this chart out. It's yes, no in the squares. So here's a big long number, 831,247. Ends in a 7, which is not an even number. It's not a 0, 2, 4, 6, or 8. So it is not divisible by 2. Okay, so divisibility by 3. Similar rule to 9. So we'll look at 3 and 9 at the same time, and we'll take a look at that rule, which is 3. If the sum of the digits is divisible by 3, then it's divisible by 3. If the sum of the digits for 9 is divisible by 9, then it's divisible by 9. So the sum of the digits, meaning you add the digits of the whole number. So we'll look at doing that. So 7, let's see, we're looking, right now we're going to decide these two together since it's the same rule. So we're going to add the digits, step 1. So I'm just writing that down so you know what I'm doing. So for the first one, 7 plus 5 equals 12. We're getting that because we added these two numbers. This whole number is 75. That doesn't change the whole number. We're just adding the digits. It's a trick, essentially. It's just a little trick. And this number here is 12. So does 3 go into 12? Yes, it does, because 4 times 3 is 12. So 3 goes into 12 4 times. So in other words, that's like saying it this way. 3 goes into 12 4 times. 4 times 3 equals 12. So yes, 75 is divisible by 3. Is it divisible by 9? We can look at it at the same time because it's the same rule. You add the digits and you look at your answer, 12. Is that divisible by 9? In other words, does 9 go into 12? Evenly. Does it go in there evenly? Well, not really. Because if you have 1 times 9 is 9, then you've got 3 left over, and you got a remainder. So, remainder of 3 So this is not divisible by 9. That means the whole number 75, the whole thing is not divisible by 9. Whereas it is, in fact, divisible by 3. The whole number 75 is divisible by 3. So this one is not divisible by 9. So let's do the next one. The digits 1 plus 8 plus 0 plus 0 equals 9. Aha! So the question is, you added the digits and decide, is it divisible by 3? You look at what it adds to, and does 3 go into 9? Yes, it does. So yes, the whole number 1800 is divisible by 3. Then you ask yourself the same question, does 9 go into 9? Because now we're looking to see if this whole number 1800 is divisible by 9. So it's the same rule, you add the digits, and we did that, we got 9, so we're questioning, just like we questioned here. Now we're going to question, does 9 go into 9? Well, of course it does, one time. Okay, so then this big number 1800 is divisible by 9. 516. Is 516 divisible by 3 or 9? So let's add our digits. 5 plus 1 plus 6 equals, that would be 6 plus 6, because 5 plus 1 is 6, 12. Okay, so we ask ourselves, we look at these two situations. I'm going to move it over here so I don't have to erase it. Does 3 go into 12? Question mark. Does 9 go into 12? Didn't we do this before? I think we did. Woo! Yes, 3 goes into 12 4 times. 9 does not go into 12 evenly. There's a remainder of 3, as we sorted out before. So it is not divisible by 9. No. But it is divisible by 3. Yes. Okay, and let's look at this big number here. So we have to do 8. Alright, let's do some fancy adding here. 1 plus 2 is 3, plus 3 is 6, plus 8 is 14, plus 4 is 18, plus 7 is 25. Do I trust my math in my head? Well, I can do it backwards. 7 plus 6 is 13, 14, 15, 16, 17, plus 8 is 25. Okay. And we got this number, and we have to ask ourselves, does 3 go into 25? So we're asking, does 3 go into 25? It's just a way of making this big number more manageable by adding those digits and deciding it doesn't work with all of these rules. All the digits don't work this way, but so I kind of see 3. So no, it's not divisible by 3. If you go 9 into 25, so no, it's not divisible by 9. Okay, so we've made quite a few decisions here. So what we have left then is 5 and 10. And we can look at those at the same time since they're so similar. The rule for 5 and 10, if it ends in a 0 or a 5, it's divisible by 5. If it ends in a 0, it's divisible by 10. Okay, so let's go through each one. This number ends in 5. So is it divisible by 5? Yes, because the rule is if it ends in a 5, it's divisible by 5. If it ends in a 5, it's not divisible by 10 because it must end in a 0. So on this one, it ends in a 0, so there you go. We have a 10. And however, 5, it can end in a 5 and it can end in a 0, so it works for 5. 5 has 2 choices, whereas 10 just has 1 choice. This one ends in a 6, so it's not good for either one. And I like to do these together because we're looking for 5s and 0s. That's all you're looking for. 7 is not a 5 or a 0, so it goes into neither one of those. So that's it. 2, 3, 5, 9, and 10. The other divisibility rules, we can just do a quick scan at those. For 4 sometimes trips people up a little bit. Look at divisibility by 4. You have to just look at the last two numbers and decide, is that those two numbers divisible by 4? 24. So you're asking yourself this question: does 4 go into 24? Yes, it does. 6 times 4 is 24. So therefore, this number here is divisible by 4. Yes, it is. 200. Look at the last two digits. 77. 2,777. 77 doesn't have very many factors to begin with. It's just 7 times 11, and then 77 times itself is the only other factors. So 7, 11, 77, and 1. It's not divisible by 4, no. So that's a basic divisibility by 4. Now, divisibility by 6, if we read that one, if it is divisible by both 2 and 3. So you apply the tests for 2 and 3. We could look at that. And let's take one of the numbers from the problem. Let's take this one, 516. And if we want to look for divisibility by 6, actually let's look at two numbers, 1800. You apply rules for 2 and 3 to see if it's divisible by 6. Okay, so 2, are they even? Yes, that checks. Check, check, both numbers are even numbers. 3, the divisibility rule, remember, for 3 is you add the digits and you decide, is it divisible by 3. Digits, 1 plus 8 plus 0 plus 0 equals 9. Add these digits, 5 plus 1 plus 6 equals 12. So you're looking at the 3. Both of this is 3 into 12 goes 4 times. 3 into 9 goes 3 times. So we have on both numbers divisibility by 2 and divisibility by 3. So therefore, it is, in fact, these two numbers are both divisible by 6. And we have 7 has no simple test. 8, if the last 3 digits are divisible by 8. And what that means basically is if you take a number 1, 0, 2, 6, 4, you have to look at the last 3 digits, which really isn't that friendly. You know, you're like, oh, for heaven's sakes. But it could save you some time if you've got this super long number, you know, and you can go, well, at least I'll divide into this little piece at the end as opposed to the whole big number. So you would have 3 times 8 is 24. Whoops. 24. 6 minus 4 is 2. Bring down there. So in fact, because 8 goes into 264, the entire number then is in fact divisible by 8. Okay.